Hello again. In this lesson, we're going to continue our series on systems of equations in applications. So these types of equations today are going to be systems where it's kind of set up in standard form. We've usually got costs of different items. We've got quantities of different items added together, and we're going to set up a system to solve them. So this example says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. So a good place to start is to think about what they've asked you to find. Either find this or what is this. That's going to be a good indication of what your variables should be. So let's go ahead and define our variables. So find the cost of each. Cost of each meaning cost of the box of envelopes and the cost of the box of notebook paper. So I'm going to go ahead and just say X equals the cost of boxes of envelopes. Actually, I should say a box of envelopes. A box of envelopes. And we'll let Y equal the cost of a box of the paper. Great. So we're told that 3 boxes of envelopes and 4 boxes of paper is $13.25. So we don't know what the envelopes cost, but if we bought 3 of them, well, that would be a cost of 3x, 3 times the cost of each of them. And 4 notebook boxes of notebook paper, well, we don't know the cost of that, but 4y would give us the total cost of all 4 of those. Well, when we buy 3 x's and 4 y's, we get $13.25. So we get these very deliberate standard form kind of equation sentences here. Okay, so that's our first equation. Our second one, 2 boxes of envelopes and 6 boxes of notebook paper costs $17. Okay, 2 boxes of envelopes and 6 boxes of paper is $17. Great. So those are that creates our system of equations. And at this point, we could solve this any number of methods that we'd like. I see this system is not too bad to do by elimination. So I'm going to go ahead, I'm going to try to actually eliminate the x's here. So my choice would be to multiply the first equation by 2. And I'm going to multiply the second equation. My preference is to multiply it by a -3 so that those coefficients will be opposite in sign. I'll be able to add them together. So that first equation, when I multiply by 2, is going to give me 6x plus 8y equals $26.50. Make sure you're multiplying both sides of the equation, every term in the equation. All right, and then we multiply the second equation by -3, and I get -6x minus 18y is equal to -51. Great. Now I'm set up to add these two equations together. So when I add, the x's will cancel out, and I'll have -10y is equal to $24.50. I'll divide both sides by -10, and I'll get y is equal to $2.45. So that should be the cost of a box of paper. Let's continue to find the cost of a box of envelopes. So let's go back. I always recommend going back to the original equation. That way, if you've made any errors along the way, you just go back to the original equation where you are least likely to have made a mistake yet. So 3x plus 4 times 245 is equal to 13.25. Okay, so 3x plus this is 9.8 or $9.80 is equal to 13.25. I'll go ahead and subtract $9.80 from both sides. I get 3x is equal to $3.45, and I'll divide both sides by 3, and I get x equals 1.15. So that should be the cost of a box of envelopes. We can go ahead and check this. I'll let you do that on your own to double check, but now that we have x and y, don't just sit there and leave them as those answers. Let's go ahead and answer the question. So a box of envelopes costs $1.15. Oops, too many lines there. 15 cents. And a box of paper costs $2.45. Great. Okay, let's go ahead and try another example. It says your math teacher tells you that the next test is worth 100 points and contains 38 problems. Multiple choice questions are worth 2 points each, and word problems are worth 5 points each. How many of each type of question are there? Okay, again, look at the question. How many of each type of question are there? So X, we can let be the number of multiple choice questions. And we can let Y equal the number of word problems. Okay, so two pieces. We could attack the 100 points first or the 38 problems. Let's go with the 38 problems. We know X and Y are these two types of problems, and we know that there's 38 problems, so that must mean that the multiple choice questions and the word problems together combine to 38 total problems. To get to the 100 points, then we have to bring in the fact that multiple choice are worth 2 and word problems are worth 5. So 2 times the number of multiple choice questions will give us the points that we get from multiple choice, and 5 times the number of word problems will give us the number of points from those word problems. Well, if we add the points from multiple choice and we add the points from word problems together, we should end up with 100 points. Great. So now we have a system of equation. We can go ahead and solve this by any one of our number of methods. Let's just go ahead and do this one by substitution just to try something different. So I'm going to go ahead and take this equation. I'm going to solve this equation for X. So I'm going to subtract Y from both sides. And so X equals 38 minus Y. Okay, so if we've got X equals 38 minus Y, we can plug that in for X in our other equation. So 2 times 38 minus Y plus 5Y equals 100. Okay, so that would be 76 minus 2Y plus 5Y equals 100. So we can combine like terms. We have 76 plus 3Y equals 100. We'll subtract 76 from both sides. We get 3Y is equal to 24. And we'll divide both sides by 3. And we get Y is equal to 8. Great. Now that we have Y, the number of word problems, let's go ahead and find X. So let's go to our original equation. X plus Y equals 38. And we'll plug in our 8 for Y. So X plus 8 equals 38. And if we subtract 8 from both sides, we get X is equal to 30. Make sure you finish by answering the question and saying that there are 30 multiple choice questions and 8 word problems, and then check back with us for more systems of equations applications.